Good morning, students. Today we see about the polarizer and analyzer. In previous class we see about the what is resolution and what is the difference between interference and diffraction and what is the Fresnel distance. Okay, what do you mean by Fresnel's distance? Fresnel's distance is denoted by the letter Z, isn't it? Then what is the formula for Fresnel distance? Z is equal to a square by 2 lambda. Okay, the Fresnel distance obey both ray optics and wave optics, isn't it? Yes. Next we see about the resolution. What is meant by resolution? Then what are there are the three ways are they considered. What are they? Well resolved, just resolved and unresolved images. First case, unresolved images. If the two sources are close to each other, if the two sources are placed very close to each other, means it produces the diffractions. One diffraction is overlapped the source of other diffraction, so there is a blurred image will be produced in that case, isn't it? Yes. Next case, the two sources are just kept apart. Okay, not too much distance is between that, very small distance between the two sources is there. In that case, the diffraction of one source, that is the first maximum, is coincide with the diffraction of another minimum. Okay, that is maximum is coincide with the minimum, so here just resolved images will be produced. In last case, the two sources are kept at a distance apart. Okay, kept at a very long distances, so the diffraction produced between these two sources. Then here well resolved images will be produced. Okay, students, so today we see about the polarizer and analyzer. Okay, what is meant by polarizer and what is meant by analyzer? Before that, we see about it. We consider that we already studied in the 5th unit. Here the two sources are there. Okay, two sources are there. One is the electric field and another one is the magnetic field. Okay, both are perpendicular to each other. The electric field and the magnetic field both are perpendicular to each other. If we consider in a wave means this is the electric field wave, means this is the magnetic field wave, both are perpendicular to each other, isn't it? Yes. Next, here in this polarizer, the polarizer allows either electric field or either magnetic field. It allows any one of the field, isn't it? Yes. So that here the polarizer is the polarized, which polarizes the light passing through it, is called a polarizer. Okay, here consider, for example for the polarizer is consider the window. Okay, consider the window. Here the window's lines are arranged in a horizontal way. Okay, now I scale to this window in a vertical manner. Okay, now I pass the one scale to the vertical manner, means it will pass through the other side or not? No. Why? Because the window's lines are in a horizontal way, the scale moves in a vertical way. Okay, so it cannot pass through the other side. Suppose now I pass through the scale in a horizontal manner, means what happened? It will move to the other side, because window lines are also horizontal and the window gaps are also horizontal, the scale is also horizontal. Okay, so it moves to other side. Now in third case, now I take two scale, okay, and place just like a plus symbol. Okay, one scale is in a horizontal manner and another one scale is a vertical manner. It is just look like a plus manner. Okay, so now I pass through that scale on the other side, means what happened? Only the horizontal line only move to the other side, the vertical scale does not move to the other side. Why? Because the window is act like a polarizer here. Okay, it have only the horizontal gap, there is no vertical gap, so the horizontal scale only move to the other side. Okay, so this is a polarizer. This is the function of polarizer. Here if we pass through the both electric field and magnetic field means it passed either any one of the field only. Okay, here let us consider an unpolarized beam of light. The vibrations can be in all possible directions, all of them being perpendicular to the direction of the propagation. See the figure 7.27. See the figure 7.27 here. Here consider the source. Okay, one source is there. That source is called as the unpolarized light. Okay, that source is called as the unpolarized light. Now I passed through this unpolarized light into a polarizer. That polarizer have the vertical openings only. Okay, that polarizer have the vertical openings only. That is taken as P1. What happened? Now the unpolarized light passed through the polarizer. Only the vertical line only passed through the other side. That is called as the polarized light. Now the unpolarized light is changes into polarized light. Okay. Now that polarized light is now we have to analyze. Okay, this reaction is called as the polarizer. Then next we have to analyze the light whether it is polarized or not polarized by using the analyzer. Okay, so that one analyzer is placed here. By using this analyzer we have to see that light is the polarized, that light that come out of the polarizer is either a polarized light or not polarized light. That is called as the polarizer. Okay, then when this light passes through the polarized P1, the vibrations are restricted to only one plane. Already I said here so many planes are there. The polarizer allows only one plane, remaining planes are restricted. Okay, the emergent beam can be further passed through another polarized, that is called as analyzer. Here if the polarized P2 is rotated about the ray of light as axis for a particular position of the P2, here the intensity will be maximum. When the polarized P2 is rotated rotated from this position, the intensity start decreasing. There is a complete extinction of the light when P2 is rotated through 90 degree. On further rotation the P2 light reappears and the intensity increases and become a maximum. When it is a minimum means it becomes 0, maximum means it become have the one value. Okay, for the further rotation through 90 degree. The light coming out from the polarized P1 is said to be a plain polarized light. Already said the source is the unpolarized light. That unpolarized light is passed through the polarizer. Then the light that come out from the polarizer is called as the plain polarized light. Okay, plain polarized light. Next, here the polarized P1 in which the plane polarizes, the unpolarized light passes through it is called as a polarizer. The polarized P2 which is used to examine whether a beam of light is polarized or not is called as the analyzer. Okay, if the intensity, already I said the intensity of the unpolarized light, okay, before passing through the polarizer the intensity of the unpolarized light is denoted as I. Intensity is denoted as I. Then the intensity of plane polarized, what is the intensity of plane polarized light? I by 2, because only half of the ray only passed through the polarizer. So that here the intensity of the plane polarized light will be I by 2, because the half of the intensity is restricted by the polarizer. Remaining half only it will come out from the polarizer. So the intensity of the plane polarized light is denoted as I by 2. Okay, next we see about the plane and partially polarized light. What is plane polarized light and what is partially polarized light? In plane polarized light the intensity varies from maximum to 0 for every rotation of 90 degree of the analyzer. When the analyzer rotate every 90 degree, it goes to maximum to 0, then again it goes to maximum to 0. Okay, like that the plane polarized intensity is varied. Okay, then this is because the vibrations are allowed in one axis and completely restricted in perpendicular axis. இது எதனால நடக்குன்னா வைப்ரேஷன் வந்து போலரைசரில் வந்து ஒரு ஆக்சிஸில் மட்டும்தான் பாஸ் ஆகும். ஆல்ரெடி சொன்ன மாதிரி தான். இப்போது நம்ம எலக்ட்ரிக் ஃபீல்டு மேக்னெட்டிக் ஃபீல்டு இருந்தால் அதில் ஏதாவது ஒன்று மட்டும்தான் போலரைசரில் பாஸ் ஆகும். so that only this will be happen. Okay. On the other hand, if the intensity of light varies between maximum and minimum for every rotation of 90 degree of the polarizer, this light is said to be the partially polarized light. But in partially polarized light, the intensity varies to not comes to the zero, it comes to maximum to minimum, then again it goes to maximum, again comes to minimum, then maximum, minimum, like that it will be moves on. Okay, this is called as the partially polarized light. Why this is? Because the light is not fully restricted in that particular axis which shows a minimum intensity. இது வந்து full that polarizer cannot fully restricted the light, it allows partially. Okay, so that this minimum and maximum will be happened. Okay, then see the figure 7.28a and 7.28b. First we see the 7.28a, that is the plane polarized light. Here the x-axis is taken along the angles 0 degree, 90 degree, 180 degree, 270 degree and 360 degree, like that. Then intensity is taken along the y-axis. Okay, first it moves on, it reaches the maximum value for the plane polarized light, then again the next 90 degree rotation it comes to the 190 degree. Okay, then again next 90 degree rotation it moves to the maximum value, then again next 90 degree of the analyzer rotation it comes to the 270 degree. Okay, like that it reaches the maximum to 0, then maximum to 0, then maximum to 0, like that it moves on. But in partially polarized light it does not come to the 0 state, it first it reaches the maximum to 190 degree, then again it reaches the minimum to next rotation, then again next rotation it reaches the maximum value, then next rotation it reaches the minimum value, like that it moves on, maximum to minimum, then again maximum to minimum, then again maximum to minimum. Okay, so this is the plane polarized and partially polarized light. The intensity is varied. For plane polarized light the intensity varies from maximum to 0, maximum to 0, but in partially polarized light it does not restricted, it allow partially. Okay, so that it reaches it does not reaches the 0, it reaches maximum to minimum and maximum to minimum. Okay, have you all understand? Okay students, next we see about the important 3 mark question, Malus law. Okay, Malus law. In this Malus law, here we already know that what is the intensity formula. Intensity is directly proportional to, intensity is directly proportional to square of the amplitude, isn't it? Yes, intensity is directly proportional to the square of the amplitude. In this experiment, in this law, the French scientist, French physicist Ian Malus introduced Ian Malus prove that this equation. Okay, I proportional to a square, that is intensity is directly proportional to the square root of amplitude. Okay, so that Okay, in this Malus law, in 1809, the French scientist Ian Malus discovered that when a beam of plane polarized light of intensity, that plane polarized light have one intensity that is denoted as I naught. Okay, it is that polarized light is incident on the analyzer. Okay, that polarized light is incident on the analyzer. Now, the light transmitted of intensity I from the analyzer varies directly as the square of cosine of the angle theta between the transmission axis of polarizer and analyzer. Okay, see the figure 7.29. First one unpolarized, that is the source, light source, unpolarized light is passed through the polarizer, only a particular axis only, particular direction only allowed. Okay, so that intensity or that light intensity is taken as I naught, that is the polarized light intensity is taken as I naught. Now that polarized light is allowed to pass through the analyzer, but here the analyzer is tilted. Okay, the analyzer is tilted to the 90 degree. Okay, the analyzer is tilted to the 90 degree. Here this is that light, this is the polarizer, but here the polarizer is tilted to 90 degree. Okay, so that here the intensity which is equal to, we have to prove that I is equal to I naught cos square theta. We have to prove that I is equal to I naught cos square theta. Okay, this scientist Malus prove this equation by using this experimental setup. Okay, I equal to I naught cos square theta. Okay, here I said this analyzer is tilted to 90 degree means it resolved into two components. Okay, it resolved into two component. One is horizontal component and another one is vertical component. Okay, here one is the horizontal component and the another one is vertical component. Okay, before that, here the analyzer varies directly as the square of cosine of the angle theta between the transmission axis of polarizer and the analyzer. This is known as the Malus law. We have to prove this I is equal to I naught cos square theta. The proof of Malus law is as follows. Now we have to prove this Malus law. I already said this analyzer is tilted to 90 degrees, so it is resolved into two components. What are they? One is horizontal component and another one is vertical component. Okay, so that here let us consider the plane of polarizer and analyzer are inclined to each other. It make an angle theta. Okay, see the figure 7.30. It make an angle theta. Then let I naught be the intensity and A be the amplitude. Okay, I naught be the intensity and A be the amplitude. Here the amplitude of the electric vector transmitted by the polarizer. The amplitude A of the incident light has two rectangular components. Already I said it results into two components. One is A cos theta and another one is A sin theta. Both are parallel and perpendicular component, okay, to the axis of transmission of the analyzer. Then next, only the component A cos theta will be transmitted by the analyzer. Okay, why? Because we need not taken as the vertical component. So here the A cos theta only transmitted to the analyzer. So the intensity of light transmitted from the analyzer is proportional to the square of component of the amplitude of transmitted by the analyzer. நமக்கு already என்ன தெரியும்? The intensity I is directly proportional to the square of amplitude. Okay, here what is the value for amplitude? A cos theta. So instead of this A squared, we have to put I directly proportional to A cos theta the whole square. Okay, in next step we have to taken as I directly proportional to A squared cos squared theta. Okay, A squared cos squared theta. Then next I want to take the proportionality. Okay, if I want to take the proportionality means we have to add one proportionality constant, so that here they add. So here they add, wait, so that here they add I which is equal to k A squared cos squared theta. Here k is the proportionality constant. Okay, I is equal to k A squared cos squared theta. Then I is equal to, instead of this k A squared, I put I naught. Here I naught is the maximum intensity of light transmitted from the analyzer. So I which is equal to I naught cos squared theta. You all understand? I is equal to I naught k cos squared theta. We want to prove this equation only. So Malus proved this equation. You all understand? So next, here it consists of two cases, okay, two special cases. The first case is when the angle theta is which is equal to 0 degree means what is the value for cos 0? 1. So the intensity I which is equal to I naught. because the theta value which is equal to 0, so cos square 0, cos 0 value will be 1, so I is equal to I naught. Then the second case, in this case that theta is equal to 0 when the transmission axis of polarizer is along that of the analyzer. Here the intensity of light transmitted from the analyzer is equal to the incident light that falls on it from the polarizer. That means here the intensity of the analyzer light will be equal to the polarizer light. Okay, that will be same. In next case, second case, here the theta value will be 90 degree. If the theta value is 90 degree means cos 90. What is the value for cos 90? 0. So cos 90 which is equal to 0, the intensity I is equal to 0. So I which is equal to 0 in this case when the transmission axis of polarizer and analyzer both are perpendicular to each other, so here the intensity will be 0. The intensity of light transmitted from the analyzer is also 0. Have you understand? This is the very important 3 mark question, Malus law. Okay, so what is Malus law? Malus law was in 1809 the French physicist E.N. Malus, he discovered that when a beam of plane polarized light have some intensity that is taken as I naught, then that polarized light intensity is allowed to pass through one analyzer, but that analyzer is tilted to 90 degree, so it resolved into two component. One is vertical component and another one is the horizontal component. Okay, so Malus law want to prove that I is equal to I naught cos square theta. Okay, so next we have to prove that Malus law. So already I said here the amplitude is resolved into two component. One is A cos theta and another one is A sin theta. We want only the A cos theta, that is the horizontal component only. Here there is no use of the vertical component, so we neglect that A sin theta. Instead of that, what is the amplitude for a horizontal component? A cos theta. We already know that. What is the intensity? Intensity is directly proportional to the square root of amplitude, isn't it? Yes. So that here I directly proportional to, instead of A, here what is the amplitude? A cos theta. Okay, instead of A, here the amplitude is A cos theta, so I directly proportional to A cos theta the whole square. In next step I directly proportional to A squared cos squared theta. Okay, now I want to take this proportionality. If we want to take the proportionality mean we have to introduce one proportionality constant. So here I introduce the proportionality constant K. Okay, K is the proportionality constant. So I which is equal to K A squared cos squared theta. Here instead of this K A squared, I want to put I naught. Here I naught is the maximum intensity of light transmitted from the analyzer. So instead of this K A squared, I put I is equal to I naught cos squared theta. Okay, hence proved. Okay, next it consists of two cases. What are they? In first case, the angle theta will be 0 means it produces the, what is the value for cos 0? 1. So the intensity I which is equal to the maximum intensity I naught. It produces the maximum intensity, that is here the transmission axis of polarizer is along that of the analyzer, that is the intensity of light transmitted. Analyzer that light that released from the analyzer is equal to the polarized light. Okay, so this is the first case. In next case, now the theta value will be 90 degree means what is the value for cos 90? 0. So the intensity is also become 0. So I which is equal to 0. Here the transmission axis of polarizer and analyzer both are at a perpendicular direction. Okay, both are at a perpendicular to each other. So here the intensity of the light transmitted from the analyzer is 0. Okay, have you understand? So this is the Malus law. Okay, here the one main thing, here the analyzer is tilted at the 90 degree, so that only it result into two component. One is horizontal component and another one is vertical component. We have to take only the horizontal component, that is A cos theta, that is the amplitude. So instead of this amplitude I is I directly proportional to A squared. What is the amplitude here? A cos theta. So A square cos square theta. Okay, have you all understand? Okay students, next we see about the uses of polarize. Uses of Polaroid. Okay, take page number 84. Uses of Polaroids. First, the Polaroids are used in goggles. What is meant by goggles? Like a mirror, okay, kannadi, and cameras to avoid the glare of light. Okay, the Polaroids are used in mirror and cameras to the glare of avoid the glare of light. Okay, then next, Polaroids are useful in three-dimensional motion picture. That is the holography, three-dimensional motion picture. They use the Polaroids. Then third point, Polaroids are used to improve contrast in old oil paintings. Improve the contrast of oil painting, they use the Polaroids. Then Polaroids are used in optical stress analysis. It is used in the optical stress analysis. Then Polaroids are used as window glasses to do you see that in some houses, in some windows, that the outer persons are not able to see inside. Okay, உள்ள இருக்கிறவங்கள வெளியே பார்க்க முடியாது, வெளியே இருக்கிறவங்கள உள்ள பார்க்க முடியாது. Okay, so in that cases they use the Polaroids because the window glasses to control the intensity of incoming light, okay, incoming sunlight, so they used. Then sixth point, polarized laser beam act as a needle to read or write in the compact disc, that is the CD marker, and that CD marker, they use that polarized laser beam. Okay, it acts as a needle to read and write in compact disc. Then Polaroid produce polarized light to be used in the liquid crystal display. Then this polarized lights are used in the LCD TV. Okay, that is the liquid crystal display. Okay, so these are the uses of Polaroids. What are the uses of Polaroids? Polaroids are used in camera and Google to avoid the glare of light. Okay, then second point, it is used in three-dimensional pictures. Then it is used to avoid the contrast in, sorry, it is used to improve the contrast in oil painting. Then it is used in the optical stress analysis. Then these are used in the window glasses to control the intensity of incoming light. Then it is act as a needle in a read and write for the CD disc, that is compact disc. Then Polaroids produce the polarized light that is used in the LCD TV. Okay, have you all understand? Okay, students, so today we see about the what is polarizer and what is analyzer and Moore's law and what are the uses of Polaroids. What is polarizer? What is polarizer? Polarizer is it allows either any one of the field, either it allows a magnetic field or either it allows a electric field. Okay, or it allows any one direction, one parallel direction or perpendicular direction, that is depending upon the polarizer. Okay, first the source is a unpolarized light. After that unpolarized light is passed through the polarizer, that outcoming light is called as the plane polarized light. Okay, the intensity of unpolarized light is taken as I, means what is the intensity of plane polarized light? I by 2, because half of the intensity will be half of the direction will be restricted by the polarizer. Okay, then what is meant by analyzer? Analyzer means that it is used to examine whether a beam of light is polarized or non-polarized, that is called as the analyzer. Okay, next we see about the plane and partially polarized light. What is meant by plane polarized light and what is meant by partially polarized light? What is the intensity of plane polarized light? Here, for every 90-degree rotation, the intensity of plane polarized light is varies from maximum to 0. Okay, first it starts at maximum and reaches the 0, then again maximum value, then 0, like that it moves on. Okay, this is called a plane polarized light. Then what is meant by partially polarized light? In partially polarized light, here the intensity varies from maximum to minimum, not it comes to 0, it maximum to minimum, again it moves to maximum and again minimum, maximum minimum, like that it moves on. Okay, so this is called as the partially polarized light because it does not completely restricted the direction, it partially allow the direction. Okay, so that only here maximum to minimum will be appear. Okay, next we see about the Moore's law. Here Moore's law was introduced by the French physicist E.N. Malus. He discovered that one beam of plane polarized light, that beam of plane polarized light have the intensity I, that plane polar I naught, that intensity I naught, that plane polarized light is pass through the analyzer, but here the analyzer is tilted at 90 degree. Okay, here the analyzer is tilted at 90 degree, so that it resolved into that outcoming light is resolved into two component. One is vertical component and another one is horizontal component. We have to take only the horizontal component, that is the amplitude of that analyzer light is called as the A cos theta. Okay, here the modulus law want to prove I is equal to I naught cos square theta. So here we take I directly, we already know that the intensity is directly proportional to the square of amplitude, that is I directly proportional to A square. Here what is the amplitude? A cos theta. So I directly proportional to A cos theta the whole square, then I directly proportional to A squared cos square theta. Now I want to remove them proportionality. If we want to remove the proportionality means we have to add one constant term, so I add k here. So I, which is equal to k a squared cos square theta. Okay, instead of this k a squared I put I naught. Here I naught is the maximum intensity. So finally we get a value I, which is equal to I naught cos square theta, hence verified. Okay, next it consists of the two step. In first two cases, in first case the theta value will be 0. If the theta value will be 0 means what is the value for cos 0? 1. So the intensity which is equal to maximum intensity I naught. Okay, so I is equal to I naught. Here both the analyzer light and the incident light are both are equal. Okay, the intensity of analyzer light and the incident polarized light both are equal. In next case, here the theta value will be 90 degree. If the theta value will be 90 degree means what is the value for cos 90? 0. So the intensity will be 0. In this case, the analyzer, that polarizer and the analyzer both are perpendicular to each other, so the intensity will be 0. Okay, then finally we see about the uses of polarites. There are the 7 uses are there. They are used in the camera, then it is used in the oil painting to improve the contrast, then optical stress analysis, then it is used in the window glasses to control the intensity of incoming light. Okay, so these are the uses of polarites. Okay students, have you all understand? If you have any doubt means you ask. Okay, so thank you students. So I hope you all study. Already I give some questions. Today's homework is you have to write that I give some question, isn't it? Yes, you have to write that first 10 2 more questions, 2 more 3 more questions, first 10 you have to write in your homework note. Okay, study and write, don't waste that time. Okay, thank you students.